Okay, so buckle your seatbelts. We're going to be doing some algebra. So just as a reminder where we were, we had this differential equation right here. Whoops. That's right here. We had the differential equation. We found that by taking the Laplace transform, we ended up getting this expression. And so when we solved for our capital Y of S, we ended up with this expression here. And so we want to think about this expression in this form, because if we write it this way, then we can write our the final answer to our differential equation in this form. And so now, at this stage, all we have to do is really just focus our attention on h of s and invert that, and that will be plenty. Okay, let's see what we got going here. So let's go ahead and rewrite our h of s. So h of s is 3 halves times, well, sure, 1 over s squared times s squared plus 3s plus 2. And now I'm getting myself ready for some partial fractions, and so I need to look at my quadratic, and I do see that in this case it is factorable, right? So that's s plus 1 times s plus 2. Therefore, using our tried and true partial fraction decomposition, I'm going to get rid of my 3 halves here. This is going to be a over s plus b over s squared. I'm treating s squared as a repeated root, although you don't have to, plus c over s plus 1 plus d over s plus 2. And so you can tell here that we're going to be doing some algebra. If I clear the fractions on both sides, I'm going to end up with 3 halves on this side, and then I'll have and s will cancel, but I'm be left with s times s squared plus 3s plus 2. I'll go ahead and keep that as multiplied through there. Let's see if I can write nicely, because we're going to have lots of algebra here. So b, the s squareds will cancel, and I'll just be left with my polynomial, 3s plus 2, plus c, and now the s plus 1 cancels, so I'll be left with s squared times s plus 2 plus d, and that will be, let's see if I can fit it all in, s squared times s plus 1. Good. Now I need to solve for a, b, c, and d. But actually it's not as bad as it looks. If you go ahead and expand everything out, 3 halves is equal to as cubed plus 3as squared plus 2as plus bs squared plus 3bs plus 2b plus cs cubed plus 2cs squared plus ds cubed plus ds squared. And now we just equate coefficients. S cubed, 0 equals, and then on this side, let's see, where are my cubic terms? I've got one there, got one there, got one there. Okay, so therefore I've got a plus c plus d. Good. Now s squared terms. Let's see, s squared terms. Oh, let's use a different color, green maybe. S squared term there, s squared term there. Any more s squared terms? There's one, and there's one. Wow, there's 4 of them. Okay, so therefore 0 is equal to 3a plus b plus c, plus 2c plus d. And our s terms are, where do you see s terms? There's an s term, there's an s term, and that's it. That's not bad. S terms are 0 equals 2a plus 3b. And then finally, constant 3 halves is equal to, do you see that the only constant here is 2b? So therefore, our b is 3/4. b is 3/4. And so using the next equation then, I can solve for a, and it turns out that a is minus 9/8. Do you see that? Okay. And now if I plug these two numbers into these two equations, I get that c plus d is equal to minus a, which is 9/8. And then I get 2c plus d is equal to minus 3 times a minus 9/8 minus b, which is 3/4. And so if you solve these equations, I think what this is 21/8. Okay, and solving these, there are several ways to do it. We'll just go ahead and write down our answer, which is, let's see, c equals 3/2 and d is equal to minus 3/8. Good. So now we have our solution. Let's see. So what we have here is that h of s was equal to minus 9/8. Go ahead and scoot that up. Minus 9/8 times 1 over s plus 3/4 times 1 over s squared plus 3/2 times 1 over s plus 1 minus 3/8 times 1 over, well, let's see, s plus 2 I think was the last one there. Very good. All right, so now we can just go with our h of t, and our h of t is equal to minus 9. Let's see if I can draw that a little better. Minus 9/8. 1 over s was the Laplace transform of 1, plus 3/4 times t plus 3/2 times e to the minus t minus 3/8 times e to the minus 2t. And there we go. There's my h of t. And remember that that's not the actual solution, right? This was the solution here. Okay. So algebraically, that's kind of a mess, but if you just follow the steps, it's not too bad. And so in this case, we had a big, giant partial fraction problem to solve, but it solves fairly quickly if you just go carefully through it. And okay, we will stop there with this example, and I'll probably just go on to the next section now. Okay, see you in the next video.